everyone, and welcome to another video. Today we are going to be coding stacks and queues. So in the prior video, I showed you the basic concepts and I kind of give you an idea of how to implement it using both a linked list and an array for both stack and queues. So that's 4 combinations that you have basically. But of course, it's always nice to see some code. And so I thought, let's just do a video where we just code it. Now, it does take a while to code all 4 combinations. So you have stack and queue and linked list. Then you have stack and queue in array. So that's 4. So it takes a while. In the prior semester in 202, I did it over 3 courses, 3 days. And I will leave a link in the description below to those videos if you want to watch me code them live. So this time, so that I can kind of get it done in a more viable time, I'm gonna skip some steps and maybe reference some of that code because I want to show you how it works, but it does take a long time, and it's more time than I'd rather spend. Last time around, I did it because we had so much spare time, and so I was like, why not? But it does get pretty gruesome after a while just watching somebody code. So I'm going to go over the main points, and that's really what I think will help you if you implement it. And also, if you're enrolled in the course, you can see the sample codes so that you can see those and play with those as well. Okay? So I'm going to start with the more useful one, which is, at least in my opinion, which is the linked list implementation of that. So I'm going to implement both a queue and a stack using a linked list, and as a reference, I'm going to use what I did in 2021's fall semester implementation. Okay. In fact, I'm gonna simplify it maybe by getting rid of the templated, just to avoid having to keep writing the word templated around. I know that in that version I had it templated, but it'll save me just a little bit of time probably. So yeah. Okay. Let's get going on this. So the first thing is, you're still gonna have a node. Like, there's no way around it. If you're using a linked list, then you're dealing with nodes. Now I'm gonna make a type. I'm just gonna make it store integers. It'll make our life easy that way. Why is this all underlined? Let's just make sure it runs. Incomplete type is not allowed. That's what happens when you copy paste code. Now you have to figure out why it's not working. Node D. Oh, well, it's a type. There we go. Okay. So yeah, we're good now. All right. So basically, we still need a node to have a linked list, but what's going to change is our linked list class. So instead of making a linked list class, I'm going to go ahead and make a stack class. Okay. So, or actually, yeah, let's do stack first, and then we can do a queue. All right. So the class stack is going to have a constructor, and that constructor is going to just initialize our top pointer, right? So we need a top pointer that is going to act as our head, and so that's basically going to be what allows us to keep track of what is in the stack. In addition to that, we're going to need to do a count to keep track of how big the stack is. So, you could make these public or private at the top, or I'm just going to make everything public to make my life easy. Not to have to access our functions and whatnot. So, yeah, we'll do top and size. The size should be initialized to 0. Doesn't matter if you do that here or in the constructor. And you don't have to give it a size because it's a queue, so it'll grow dynamically. And again, you should initialize top here to be null, which you can do this way. Ooh, nil. Or you could do it like I did with the size, right? So either or will work. In fact, I'm gonna be consistent and do that. Just to avoid, I always do it different ways to show you different ways of doing things, but it is not the way you want to code. You want to code in a consistent way. So it does bother me sometimes. So today, let's make it look consistent. Okay, and yeah, so what are the two operations that we need to have in here? And those are the push and pop. So push is kind of like, if you think of like way back when you learn about accessors and getters, you know, accessors like return stuff and getters are like void functions usually, or sorry, getters and setters. So getters return stuff and setters are void. So you can think of this like push is going to be a void function, but it's going to have a parameter, which is what you're pushing in. So I'll call it, well, I can call it D, but it's going to have naming issues and I have to use this pointer or something. So let's just call it I or something. And then the other function you want to have is the pop one, which is going to return to us what we pop out of the stack. Okay, and that's really it. I mean, actually, so far I haven't even referenced the code that I have. Let me take a look at that. I wonder if I did something different. Nope, it's all pretty much the same except that was templated. So, well, I had some nastiness. If you see those videos about the empty symbol, that's because, like, what happens when you pop from an empty stack? You need to return something because this is a valid returning function, right? So in this implementation that I'm going to do today, we just hope that that never happens. And how? Well, make sure they check the size. Is that an okay assumption to make? I think so, because at the end of the day, you know, you shouldn't be in the first place like having code that's going to remove stuff from an empty stack. That should just not happen, especially if you have something that you can check before you do that. So that's why we're going to make that assumption. But if that's not an assumption you got to make, then you need to figure out what you would return, like maybe a -1 in this case. But what if this is not? What if this is template? Then you have no idea what type to return. So that's why you'll see that weird code there. Anyways, so yeah, at this point we are basically ready to go to just start adding those two functions. So, oh, and I guess we also need to have a destructor, right? So to avoid memory leaks. So we'll come back and do that after we finish. But yeah, so the first thing you want to do when you push into the stack is you want to create a new node that's going to contain the data. So and make a temp pointer. So node pointer temp is going to have a new node with I in it, right? So I'm still using the same implementation I did when I did my node linked list that has a constructor that requires the data to be put in and initializes or pointer to null. Oh, I see I'm using null PTR here. So talking about consistency, we probably should stick to using null PTR. So yeah, but yeah, that's how that gets made. And so now that we've made that, again, when you're implementing a linked list, a stack linked list, what you want to do is you want to insert the beginning of it. So got some nodes in here, don't I? Delete them all. Oh no, here we go. So you want to keep your top pointing to the beginning, and whenever you make a new node like this, make it point to whatever top's pointing to. That's step 1, and step 2 is update top to point to the new node. So there's 2 pieces of code that we need to put in there. We could probably make it a single line if we're fancy, but could we? I don't know. But yeah, so right now, I guess technically there are several scenarios like with inserting linked lists that we got to consider, right? Not several, but at least 2 scenarios. One of them is that the list is empty, and the other one is the list is not empty. So let's just have that checked first. How do we know if it's empty? Well, if it's empty, top should be equal to null. So if top is equal to null, empty list, then just go ahead and say top gets the new node. And you're done at that point. So you're good to go now. Otherwise, so in this case, it's not empty. Then you have to do that two-step process that I showed you. So I'm going to say temp next is going to get top, and then update the top to point to temp, which is the first node. Because if I draw the what this is called temp, what I'm saying is, and then this arrow here is technically temp next, right? So I want to update that to point to whatever top is currently pointing to, which is this. So temp. So that's why I say temp next gets whatever top is pointing to. So that'll make sure that I am pointing here. And then I just want to update top to point to whatever temp is pointing to. So hopefully this is all kind of easy now after you learn linked list. I did call it N for next instead. So I am actually gonna, okay, I know I did that to save space. So yeah, let's do that. Let's commit to the same system. So N for next and D for data, okay? So other than that, here we're pretty much all set. By the way, I want this to be D for data. I don't think it'll be confusing. I do think in theory, could we? Nah, I was trying to see if we could make this into a single line, but nah, it's just gonna make it unnecessarily confusing. Okay, so yeah, this is pretty much it. That's all there's to it for push. For pop, you have the two scenarios again, which are, well, there's three scenarios, but one of them we're ignoring, which is where like you're trying to pop from an empty list, because that will just end badly. Yeah, it'll just end line. I mean, we could throw an exception, like I haven't done exceptions in a while, but I guess try catch block. So no, let's not do that. Again, the scenario is if top is equal to null, this is bad, right? Because we're trying to pop from empty stack. So you don't want to have this scenario happen, and there's really nothing you can do to stop it other than like putting it in the if statement and all. But you're going to get a compilation warning or error if you don't have a return statement. So like, yeah, I mean, like I said, the only thing I can think of that we could throw in there is like a try catch block maybe, or to throw an exception maybe. That could probably be. To do that, so let me look up some examples. I haven't done that. Could I just throw and then trying to figure out what I want to throw? Well, we can do a runtime error, I guess. So I'm gonna say yeah, and then throw std. Runtime error. And actually, let's put this in there. Okay. And then I don't think now it'll complain if I compile, but who knows? I don't think I need to do anything other than that. Okay. Well, semicolon. Anyways, so assume that we don't have that scenario, right? So in the other two scenarios is that we are popping something and it's the only item, so now it's empty afterwards, or a scenario where we just pop and there's still more things after it. So the only difference that's going to make is what top gets set to, right? So if it gets set to null or if it gets set to the next thing. Fortunately, because we coded this right, the last node in the linked list is already pointing to null, right? Like the last node's next is pointing to null. So that won't be an issue because in both scenarios, it'll set top correctly. So all I gotta do is I'm gonna make a temporary variable. So I'm gonna call it temp, I need both a node temp to avoid dangling pointers, which I'm gonna store the top to. And then I'm going to go ahead and make a temporary integer. That's going to be my data that I'm going to return. Okay, and I'm going to basically store temps next, or we can do it in terms of top. We're going to store tops next there. So I'm going to basically make a copy of the data, or so not next data. And then now I can go ahead and update top to be to the next item. So top is going to be whatever top was, but the next item in the node. So that means basically, from a drawing perspective here, if I take this code, copy, also get rid of this. Now I don't need it. It's going to be confusing. I want to do it over the over this one because it's today's code. So right now I have temp like this. So temp is pointing where it should be and everything. And so temp gets top means that I have temp pointing to this node that I have here. Very cool. Now I'm making a temp, an int data that is storing this information there. So like, I don't know, let's say it's a 2. So it stores a 2. Now I'm updating top to be whatever top is currently at. So top next is at. So top next would be the equivalent of whatever this arrow is pointing to. So this would be the next node. So this node. So I'm updating that so that by saying top gets top next, what that does is it basically moves this forward. And now I'm ready to go ahead and deallocate this. So I want to delete this by calling delete on temp. And then I want to return this from the pop function. So yeah, that's pretty much what I want to do. Okay. So let's go ahead and say delete temp. No memory leaks allowed. I don't need to set it to null because it's in the function, and when I return it, it'll be lost, the link, so not a problem there. And then just say return D. Okay. So yeah, and I really do need this because otherwise, if I said return temp D, like background would yell at me because I'm accessing it, I'm dangling pointer right through that. So that's why I need this. And then I need this temp node so that I can delete this, because if I try to delete this before updating this, I'm also accessing a dangling pointer. So, or sorry, before I update this, that's bad too. So you have to have these lines in this order. Otherwise, you are technically doing something bad, even though it might work otherwise, okay? But yeah, the cool thing about this is that if it's the last node, this will be set to null. So it'll just set top to null, meaning that it will already kind of be left in a good state for us to be able to insert into an empty list in the future, or to throw an exception if we try to pop from an empty list. That is it. This is it. This is literally a stack implemented now. We have completed implementation. Let's just go ahead and test it. The spacing is broken. I don't like this. I like it when it's 4 spaces. But yeah, so let's just say stack s. So s dot push. Let's try pushing something in, and then let's try pushing another number in, and then let's try popping a number. Let's see out what it pops so that we can see that it actually worked. And then let's pop another number, and then let's try popping after that. Well, actually, let's comment that out, because that will give us an error later. So I want to test that. Throw exception handling, see if it actually throws that. Let's push one more in first. Okay. Oh, I guess, you know, we do want. Let's do one more function. 2 more functions technically. The destructor. We haven't done the destructor yet. So the destructor is just like when we finish this, the stack should be empty in theory, because we should probably still have stuff in there. But just in case we do, let's just delete it all by you know, running a while loop that says while top is not equal to null PTR, I guess. I've been using null when I should have used that because I want to be consistent. So you just change those to null PTRs. You could use find and replace, but too much effort. Yeah, so while top is not equal to null PTR, we need a temporary node pointer to not have dangling pointer. So temp gets top, delete temp, and top next. Okay, so that should do it for the memory leaks. That really does bother me, so I'm going to space that like that. Okay. Similarly, if I want to have a print function to analyze the contents of the stack, I can just say wow, and then just make a note. Cur gets top. While cur is not equal to null. I can just say cout cur data. Yeah, let's see out line there. Okay, that should do it. So now we can actually print out the contents of the stack so we can see it better. And then one more that we will have, but I will run it afterwards. So let's see what we got on errors about. Oh, we need void. Okay, so we got an exception. Segmentation fault. Ooh, why? Well, cur is not equal to null. Cur top gets top next. Oh, yikes. Cur, not top. I can only do the top thing in the destructor because I don't need top anymore. Otherwise, like, you want to have that. Okay. So anyways, let's see if this works. So we push a 1, we push a 2, we push a 3. We print out the stack. We can see that it holds a 3, 2, 1. That's what we expect because remember that if we pop, the 3 is going to come out first. So that's what's at the top right now. As you can see, when we do pop, we can see the 3 comes out, then the 2 comes out. We print the constant, there's still a 1. We print it, then we print the stack again, and it's empty now. Until now, in fact, we can do a little, we can say if top is equal to null ptr, we can see out empty is, or just empty. So now it looks prettier because it says stack empty. The dot looks weird though. Let's get rid of that. So yeah, it works fine. So let's try to see what happens if we pop from an empty stack. Exception has occurred. So our exception is thrown successfully. And it says here, terminated call after throwing an instance of std runtime error, pop from empty stack. So yeah, that's good. We want that error. It's probably a bad thing if they're popping it. They gotta fix whatever algorithm they're running on that's making you pop from an empty stack. So yeah, how would we avoid this? We could do an if statement that says if size is greater than 0. Oh, you know, talk about size. I forgot about that totally. We never updated our size variable. So we should do that. We can do that very easily. Just at the bottom of the push, do something like size plus plus. And then at the bottom of the pop, do size minus minus. And that should be good as long as the instance gets thrown, you'll still get that error. So yeah, and if we want to see if that works, let's just add that into our loop. So maybe after the loop runs, we have a cout statement that has a size. So 1, 2 spaces, size, and then an end line. So now Okay, yeah, I understand. I need to put a semicolon there, and also let's comment out the exception for now. So we don't need the stacks and queue thing anymore. So you can see the size is 3, size is 1, size is 0, and then if we do bring our exception in, then yes, we do get that exception thrown. Let me show you that exception actually in the terminal, so you can see what it looks like. Oh gosh, did I just crash Ubuntu? Oh no, Valgrind crashed. Probably because I can't handle that weird exception. But yeah, you can see here, terminated call after throwing an instance of runtime error. Okay, don't send. But if we get rid of that, as in like we don't actually have bad code that would pop from an empty stack, then I'll leave it here like uncomment to see throw. I don't know if that's technically an exception, this thrown, because it's try catch, but just thinking Python in my head. But yeah, so you can see we have no memory leaks, no errors. Everything is fine. Okay, so yeah, moving on, because you can see, I mean, this is fast, but we have to do 3 more, and that will take a long time. So that's why I probably skip a little bit. So yeah, let's just add it down here. Queue. So class queue. So really, when it comes to a queue, like it's just more of the same. It's just you're gonna change how you insert things and how you remove things, but like, yeah. Other than that, I mean, like the print function will be the same. In fact, to make my life easy, let's just do inheritance. That'll be different than what I did in the. I don't think what did I do in the previous one? Did I do inheritance? No, I did not. Yeah, but we'll do inheritance here. Let's make stack. Public stack. Why am I doing inheritance? Because now I don't need to re-implement the destructor or the print function. Obviously, the print function will say stack, but you know, whatever. Big deal. In fact, I could probably do a. I have an idea for that. Let's make a variable in this class called type. That might be reserved. D type, and I'm gonna call it stack. And so here, instead of couting to make my life easier, I'll do it with no, that's bad modules. So we'll do it like that. And then here, when it says cout stack, instead it'll just say cout D type. And then we will print that out, and then that'll be good. And then now in this class, I think if we just do, if we bring in that variable again, I can just put in queue, and I think it'll work. I think. Let's try it out. Just make a queue and then just say queue print. No. Did not work. What if I got the word virtual? Oh wait, no, don't do it there. Do like virtual inheritance. I had virtual. Do it here. Nope, it still did not work. Oh, I think maybe I have to make the function virtual. I'm throwing things and see what sticks. Nope, it's still refusing to replace that variable. Okay, that's fine. That's fine. We can replace it in the constructor. So yes, we'll do that, and that will solve hopefully that issue. So queue already. I feel like I'm wasting time with this now. That's sad. We can say D type gets queue. Now will you say Q? Yes, you said Q. If I remove the virtual, will you still say Q? Yes, you say Q. Okay, so I don't need that anymore, and I don't really need this. So let's just get rid of that as well then. Okay, so yeah, that way I don't have to do the print or the constructor or the destructor. All I have to really do is add those 2 extra functions, push and pop. That's it. So, or not push and pop, but in this case, Enqueue and DQ, right? So my Enqueue function is going to have some data parameter, and my DQ function is going to be value returning of the same type that I am returning, or that I'm storing in the data set. So like that. Okay. Before I forget, size plus plus, size minus minus. So the sizing works still. Although, actually, it turns out that the way that I have the queue set up, the stack set up, I mean, inserting into the stack is really the same thing as, popping from the stack is the same thing as dequeuing. So I can just call the pop function, and it should work the same. Because both of them is basically removing the first item for pop or for DQ. The Enqueue though will be different, because in the Enqueue, with the push I'm putting it in the front, but with the Enqueue I want to put it at the back. So that will change. But for this one, it'll be the exact same. So I can save even more time by just calling that function. Problem solved. So now that I see this, all I really gotta do is one function. That's it. That's cool. Again, if you want to see me code everything piece by piece, I think in the previous semester I did code everything from scratch. Again, I gotta cut some things if I want to get this done in an hour and 15. So yeah, okay. But you can see it's pretty much the same. I mean, I could just make the function copy paste the code, but it's cooler this way actually. Okay, so for this, again, I'm calling it top, but if it was purely a queue, I would call it front and back. So what I do need to add that I unfortunately do not have right now is a tail pointer. So I need to go in and add a tail pointer into this code of the push and pop. Otherwise, my tail pointer will not work here. So I'm going to do that in the parent class to avoid issues. So I'm going to go ahead and call it back pointer. And I just need to make sure that the back pointer is always pointing to the right spot. So the way I'm going to do that is under the pop. I need to make sure that once I pop out of the stack, is there ever a scenario where I need to change the back pointer? Only if it's the only item left. If it is, then I do need to put it. So like, for example, if after this top is equal to null, then I want to set back to be null as well. Because it means the list is empty. So make sure that this is also empty. That's really the only time when the back needs to be set to null or change when I'm popping. Other than that, it should be good to go for the pop. And then for the push, I would need to modify that for it to work under the under the stack. But I'm not using it, so I'm not going to modify it now because there's no need to do anything to it. In fact, actually, looking at the only change that I did for this, I'm actually not going to do this here. I'm going to do that in the pop function here. After this. Something like that. Although, okay, I'm going to need to store a temporary variable here. So like int temp gets pop. So whatever pop gets us back. And then check this. And then go ahead and return temp. So it became 3 lines now. But yeah, because then I can actually move this back pointer into the into the inherited class and not mess with the stack. So the stack is now back to what it was before. It's back to literally, I removed any changes I had. So it's still the same one we just did. So yeah, I'm going to make all the back stuff happen in the Q class to avoid messing with the stack class or adding random half-done code. So yeah, by doing this, I make sure the back pointer is okay. And now I can just worry about back pointer being valid here when I insert. So when I enqueue, there's two scenarios for the enqueue, empty list and not empty list. By the way, I also have the scenario of popping from an empty queue, aka dequeuing from an empty queue, which will be bad. The exception handling will handle that. So we should be fine there. Yeah. So the cool thing about the enqueue is we just need to change the back pointer. So like I said, if if back is currently null, that means list is empty. So all I gotta do is say top is equal to back, which is equal to the new node that I made. So let's actually make that new node up here. So node temp gets new node D, and I'm just gonna make it point to that. Notice that I'm updating both the front and the back. The front is just an alias for back. In fact, I think I can do in C++11 an alias actually, or a type name. Let's see if I can do one of those. No, because type name is for the type names. Kind of see. There's a way you can do it, but I don't remember how to do it now, so that's fine. We'll just keep using the word top in here. But top is front, really. Okay? So, yeah. So this is the scenario where list is empty. Otherwise, it's not empty. So just append it to the end, meaning that back's next, which is currently null, is going to get temp and then make back point to temp so that it moves point back. So if you want a visual aid of that, what I'm doing is I have this, and this is currently being pointed by back. So first I make the new node I want to put in, which is being pointed by temp. And so now I'm saying take back next pointer, which is this one. So that's back next. I want to take that, and instead of pointing it to null, which is what it's pointing to right now, I'm going to assign temp there, right? Because that's going to make it point here, which is what I want. And now I just need to update back to point there. And how do I do that? I just make it point temp. Okay, so that's why the order of that matters. Okay, even though I put them like this, technically that goes beneath it, but you get what I'm saying. So that's how I came up with those two lines. Again, this should all be reviewed from linked lists, hopefully. Okay, so the head doesn't need to be changed. So yeah, that's it. We're done with the queue now. Let's see if it worked. Queue.enqueue. You know, how can I want to hide. You know, I don't like the fact that I can actually access the push and pop from the queue class inherited. But if I inherit privately, I will lose access to my print function, which I want to keep. So, yeah, whatever. So queue.enqueue, we're going to enqueue the same. So like the 1, the 2, and the 3. So basically, we're going to do the same test that we did for the stack, but I want to show you how the queue is going to actually make things nice and ordered. And then we're going to print it out, which we already are printing it out. And then we're going to see out some dequeues. So queue.dequeue and line. So we're going to do 3 of these. we'll do 3 of them. But in between these, we're going to call our print function. And we're going to call our print function here. And then we are going to try to see how it handles the errors by saying cout.dequeue. Why is it not? Oh, because it's just a space here. Q.dequeue. Okay. Comment to see error. My dog is licking my elbow. Thinks she wants to eat. Okay. So we got our queue, as you can see, 1, 2, 3 gets inserted. The size is 3. As you can see, our print function is working. You can see that with the dequeue we get 1, 2, 3, whereas with the stack we got 3, 2, 1. That's a design. Queue empty, size 0. Very good. So everything's working. Let's throw the exception. And there you go. Exception. I guess the exception says stack because it throws with the stack, but I mean, I could actually, instead of using this, I could do I think I can do something like from empty B type. I think that'll actually give me the right error. So this is from Enqueue. See that? Ah, that's cool. And let's show you that I didn't mess up the other one. Let's comment this one out. Bring this one in. See, the exception for stack will actually say empty stack. So, yep, that's cool. It's a nice little solution. Okay. So, it's okay. You'll eat soon. In half an hour. All right. So, yeah, that is how you implement a stack in a queue using a linked list. Very, very easy once you actually know how to implement linked list in general. So that's kind of a catch, that you just have to know how to implement linked list. Otherwise, you're going to struggle with this. And that really goes for most of the things in 302. You have to know how to do a bunch of 202 stuff. It's like, well, you need to know how to code to be able to code. Yeah. Okay. So now moving on into the stack Enqueue implementation using arrays. So for those, this is the ones that can be slow to code and everything. So I'm probably going to just start off by copying and pasting the code that I did before. And just looking at that one, because otherwise we will be here all day. Okay. So the stack one. The stack one's a nicer one because the trick is the circular array for the queue. For the stack, it's pretty straightforward, so I'm just going to walk you through this. So this one is templated. And so we have our stack constructor, which I just said I'm going to make it a size 3, a small size, so that I can show you the resizing. Because that is one thing that we don't have to worry about with the linked list, right? Resizing, well, that comes into play here. So we got to make sure we do that deep copying and resizing and all that fun stuff. So yeah, we start out by saying our stacks are initially of size 3. As you can see, it's a dynamic variable. And then we have a destructor and so on. By the way, we never did run Valgrind on the... it's already running on that, but I'm pretty sure it had no memory leaks. So yes, have faith. So if you don't, I can rerun it. Oh, there is an error though. I just noticed an error. Was it really an error? What's up with that? Or was that because we were error handling? Oh no, I think we did have an error. Conditional jump depends on initialized value. Stack empty size 0. What is this error that we have? There's no memory leaks, it's just an error. It's probably related to that return. So that error is coming from the line. stack empty size 0. It's probably coming out from Enqueue1. Let's try it. See, I'm glad I came back to this now, because I guess I did have one coding error on this. So let's just see. I mean, I could run a debugger, but that's not gonna tell me what's up. So because this is a Valgrind error, so I need to kind of finesse with it. So the error is coming from, I think, my enqueues. Well, why am I only getting one error instead of 3 then? So it must be the first enqueue. So when I do the enqueue, if back is equal to null, top back gets temp. Otherwise, back next gets temp, back gets temp. I don't know. Maybe it's a false positive. I don't necessarily see a problem with the code. If I run it there, do I get the error? Yeah, I do. So it is definitely happening with the enqueue. So when I call the enqueue, oh, maybe it's because back was never initialized. So technically, yeah, that's probably why it's complaining. Back was never initialized. It's still not an error the way we have it coded. But I can see why that would trigger some flags, because yeah, like it's not an error in this case, but it could be an error if, because you see, the way we know that the list is empty is we check whether back is null, right? And that's because when the list is created, we should hopefully set it to null, but we didn't. So in this case, we got lucky that back was being set to null by the compiler for us. Otherwise, this could have had issues and assumed that it wasn't empty, and the weird, scary things would have happened probably. So fair enough. It's a fair error. Good catch, Valgrind. Good catch. So there we go. Error is fixed. I'm glad we got to check that. So always check your code. Don't get cocky with the code. All right. So queue and stack linked list implementation. This is not this date. So let me change this to be today's date. Oh, that's cool. It was last time I did linked list was on the 22nd of November, and now it's the 22nd of April, so it's pretty interesting. Okay, so that was 21 for my backup codes, and then I'm also going to attach 22, which is the one from last year for linked list, and then this is the one that we're actually going to play with today, which is 23 for the arrays. Okay, so yeah. All right, so going back to this, as we can see, we have the array, size 3. We have our push function, we have our pop function, we have a top that keeps track of what the next thing to pop is. We have a print function so we can see what's up with it. And we do have a resize function. I made it private. And capacity, which I use for size. I don't know why I called it capacity other than size. So, yeah. Okay. Don't question it. Just accept it. All right. So push. For pushing in, again, it's relatively trivial because you're just adding at the end of the growing array and you have a size, given size. The other thing you got to make sure is that if you need to resize it or not. How do you check that? You check the current capacity of the array and compare it to where you're going to insert. And if you're inserting out of bounds, basically when it's equal, so when the top is equal to the capacity, that's when you know that you need to resize. So remember, top is pointing to the next available spot or to the current one. Let me see. It is pointing to the next available spot because it's inserting a top index. So what that means is that if you have 1, 2, 3 inserted and you're pointing at 4, you know, and you insert like a 4 in there, this points out of bounds now. So the next time you try to insert, you're like, hey, that's out of bounds, which means the capacity is equal to the top, right? Because capacity of this is 4, and this is technically index 4 too. So when the index of top is equal to the size, or in this case I call it capacity, that means you have to resize. Of course, I like to play it safe, so instead of saying equal, I said greater than or equal. So that's why you see greater than or equal, but equal will be fine. I saw some scary thing today with JavaScript where null, something is not equal to null. Well, I mean, if something is null, if a variable is set to null, and you say that variable is equal to null, it will say, hey, yes, it's true. So like if I have a var, and I set var to null, and then I say null equal to null, this is true. If I say null, I think it's, if I say greater than to null, so if I say, oh here, that's weird. If I say var like this, then yes, this is true because like this, right? Well, if I say var greater than or equal to null, I think this is also true. But if I say var less than or equal to null, this is false. And you're like, why? Well, yeah, because it's JavaScript. So anyways, fortunately, we're not coding in that. So yes, but try it out if you're bored over the summer. Play with JavaScript and suffer. Anyways, going back to C++ land, that's really the only reason you gotta do this check, just to make sure. If you gotta resize, and you call the resize function, which we'll see in a second, but after that, things are resized, so you can just insert by inserting at the index of what the top's pointing to, and then increasing top. This could also become one line by using post increment, not pre-increment, post increment. That's all for push. Pop is really easy. Pop is like a one-liner. All you got to do is access the index that you're currently pointing to, and then decrease top by 1. So actually, sorry, no, decrease top by 1 and then access the index you're pointing to. Because remember, top is pointing to the next available spot. So if you wanted to print out the one before, or like the top thing here, you first have to decrease top by 1 and then actually access this. So that's why it's using pre-decrement, because you want to decrease it first and then you want to access it. So if this said top minus minus, this would work. This would get you some out of bounds thing. The real trick of the array ones is the resizing stuff. Fortunately for the resizing of the array, it's not too bad. It's just a deep copy. As you can see here, I make a bigger array, hard code whatever size you want, or make it something, whatever, double the size, whatever. Do like basically just a for loop where you just do a simple deep copy. And make sure you actually update the capacity variable so that you know you have a bigger size array. Once you make the deep copy, go ahead and delete the older array. And then also make sure you update the pointer of the class that points to the array. I've seen people mess that one up too. And then you're good to go. That's it. Print function is just a for loop. And then you can see some examples of me using it here. So here we have the array. We're going to push A, B, C, D, and then 4 Ds. So basically A, B, C, D, 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 D. And then we print it out. Obviously, there's 2 resizings going on because it only fits 3. So when we get to this D, we can see that it gets resized from 3 to 6. And then when we push this D, it also gets resized again by 3. So that's why when we print it out, we see A, B, C, D, 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 and we technically have, I think, 2 more spots available. Now we pop them all out, so you can see that it pops in reverse. That's how it should work. So we got D, 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 and C, B, A, and then we're pretty much done. So yeah, that's how you do it. Again, the only tricky part is not the resizing here because it's just a for loop. It's just making sure that you know to call it, okay? Call it when you go out of bounds here. Keep track of where top's pointing to, whether you're pointing it to the last item in the list that's valid or the next available spot. You can implement this algorithm both ways, and both ways will work. Just gotta make sure you stick to one of them so you don't get confused. So Yep, that's it. So I want to leave the last 20 minutes for the Q1. So we're going to move on to the Q1. So that's 24. Again, this code will be available for you to download from Canvas if you're in the class. All right, so the circular queue. So this is a little tricky. Oh, and I guess Valgrind, you know. So the Valgrind's going to give me some errors. That's okay in this code because, oh, actually, hold on. This is for the queue. Let me rerun the array one. Because of that same issue where like we're trying to remove from an empty stack, we have no stops of that. I think that's why that one's giving error. Yeah. But yeah, on the stack one, actually no errors. Because we're not removing. But on the queue code, I guess the last thing I did is try to dequeue from an empty queue and other things. So that's why that one has giving errors. But no errors in the stack code, okay? We'll look at these errors here in a little bit. But first, let me walk you through the queue code, okay? So, circular queue. So, some things are the same. We're going to have a constructor. We're going to have a size 3. We're going to set up, instead of setting our top basically to be 0, we're going to have a back and front, just like we have with a circular queue. In fact, let me pull up a circular queue here so you remember that. So we have a front and back. We set them both to start at 0. The structure will be deallocate the array. We have our two main functions, which are the enqueue and dequeue, our front and back variables, which don't have to be pointers, so I'm making them just indices. We have a print function, we have a size, and we have a capacity. That's probably why I use capacity in the other one, because I probably coded like this first, or I was thinking of coding this, right? Because capacity, when you think about it, capacity is like how much fits in the array. Size is how much is in the array. At least that's the way that I took it. So that's why I was using capacity. Now I remember. So if you want to keep track of the size in a linked list, it's just how many items there are. But when it comes to array implementations, you need to have both how many items you have currently in the list and also how many you can fit in the list. So if you use size for both, it gets confusing, right? So I said capacity and size. So yeah. Okay. And I guess the trick here is make sure your arrays are dynamic. That's why you have a pointer here, because that's what allows me to easily resize and set the new bigger array be pointed to this by this pointer. Okay, so let's talk about the two functions, enqueue and dequeue, okay? So normally if you were doing this that way, it would just be like increase your back and then throw it in there, right? But because we're making a circular queue, we need to make sure that we wrap around when we reach the edge of it. And the way we do that is we compare the capacity of the array to where we are inserting at, okay? And in this case, we can also use modular. Modular is a much cleaner way of doing it. As you can see, this line of code is like so much easier than like having an if statement and all that. But the if statement, I think, is easier to understand than modulus operator. So that's why I left the modulus in here, but also the if statement. So really it's the same thing. So we just have to, again, be consistent about whether back is pointing to the last element of the array or if it's pointing to the spot next available in the array. And in this case, I am making it point to the spot that is next available. So in other words, back is pointing to the next available spot to insert, not to the last item in the list, which makes sense. It's kind of how I did it here, where like back is pointing to the next spot to insert, because remember, this is like just garbage data. Okay, so yes, in this case, when back goes out of bounds, it doesn't mean we gotta yet resize. It just means it's pointing to the spot out of bounds. So the next time we insert, which in this case is when we see it, that's when we say, okay, wrap back around and set it to 0. So that's why you see this here. Now, in this, how do we know when we have to resize? When back is equal to the front. That's exactly what I said in the previous video. You can rewatch that and confirm. When back and front are equal, that's when we know that we either have to resize because we are full and we're trying to insert into the front spot, which would override the front, which is not good, or the list is empty. However, how do we check that scenario? Well, we just check the size variable. So if the size is 0, then we know it's empty, so we're okay. If it's not, then that means we're actually full and we're about to overflow. So that's how I know that I gotta call the resize function there. We'll come back to resize once we'll see that later. Otherwise, it's just a regular old insert. So we just inserted an index and that's it. Make sure you increase back, which might make it go out of bounds, no problem. In the next catch, we'll set it to 0. And then make sure you increase size. Okay? Again, these two lines could be combined to this if you want to save one line. Okay, let's talk about DQ. So the DQ, you also have the situation where you might need to wrap around with your front variable. In this case, instead of the back one. So in this case, it's the same thing. If my front is currently pointing to out of bounds because I remove something. So for example, let's say that this is actually perfect here. So we have 7 is the front, right? So let me make it full screen. So we have 7 being the front, and I'm gonna DQ this out of it. Actually, hold on. Let me copy this. Copy. Oh, not duplicated. This is getting out of hand. Now there's 2 of them. Okay. All right. So we DQ this. And then front points to the next available thing, which in this case, because it's 7, it would be 8, right? So that would be pointing to 8, which should be here, but really it's pointing to 8. So that's what our DQ function would do. So the next time we want to DQ the front, the first thing we need to check if this is really pointing to a valid spot. Because we know the capacity is 8 because it goes from index 0 to 7. We know that this is not a valid index. We need to reset it to 0. Because 8 does not exist. So that's how we check. We see if front is equal or greater than the capacity. That's our flag that we need to actually change this from that to 0. Okay? So that's what we have this line of code right here. Once that is done, once that is done, I am trying to avoid like a dangling pointer-ish, although it doesn't really apply here. But it's still nice to do, is I'm making a temporary variable to store the data, and then I'm increasing my front, and I'm increasing my size, and then I'm returning temp. So I'm increasing front to point to the next available spot, which in this case will be 1, after I remove the 0. So I'm basically saying, okay, now that I fix 8 to 0, I'm going to remove what's in 0. And now I'm going to make it point to 1, because I'm going to increase it by 1, right? Now this becomes 1. So technically, this is no dangling pointer problem. So I could literally just had said return AR front like -1, and that would have been valid. But I guess I was too hyped over linked list world, and I just made it into a temporary variable. There's nothing wrong with that. I don't think that's causing the errors that we saw either. So yeah, that's how you DQ. Now resize. Resize is complete another mess. That's why you see all this stuff. The reason why is because you can't just do a for loop, right? If you do a for loop, it will not work. So you have 2 options. One of them is you can just DQ everything and enqueue it into a new one, or do some like magic with the indices to wrap things around. And so I just basically went ahead and did that. I made a new queue, essentially, DQ everything from the old one, and queue it into the new one, and then replace it. So this, of course, is probably why I'm getting some weird errors. So we'll come back to this. But after this, we have just the print functions, and then we have some test code. So let's see. Let's just rewrite the entire resize function, because it's probably what is causing us some potential grief. So yeah, okay. All right, so we're going to leave the cout statement that we have there, and then we're going to leave the new array that we're making. And then just kind of go from there. So the first thing we need to do is we need to start copying into the new one. So what I'm going to do is I'm just going to go wherever the front is, and I'm going to increase that as I remove things from there and put it into the new one. Okay? So is that going to be the best way to do it? I mean, I kind of like like how I did with the DQ, because then I can just make my life easy. Yeah, actually, we'll leave it with the DQ. So for now, yeah, we'll leave it with that one actually. So because I don't have to recode DQ when I already have it. So I go from 0 to the capacity, and every time I just take something out and I put it in the new array that I made. Okay? So once the entire process is done, I have an array that goes from 0 to whatever size, and things are in the order that I want them to be. The only thing I gotta do now is I gotta update the front and back. The front will be 0, and the back should be to the size of how many elements I had. Now, how many elements do I have? Well, if it was full before, then it's going to be the size of the capacity. So I can make back point to the capacity because it's going to be the index, the next index to insert. So that's why I have a line like this. Once I set up my front and back, then I can go ahead and update the capacity size to the new bigger array. And then I can go ahead and deallocate the old array that I have, and then store the new one. So actually, this actually was, I was talking bad about the code, but this is actually a nicer, clean way of doing it. So now I wonder why I have those errors though. Well, let's see if the output looks okay first of all. So for starters, I have ABC, and I can see here that I am queuing ABC. So that is good. And then I have D, E, F, G. Oh, well, I'm seeing resizing because of the inserting from 3 to 6 and 6 to 9. And then we got A, B, C, D, E, F, G. And then I'm printing out the empty spots. So I'm printing out the entire size of the array just to make it easier to see. And then from there, I'm going to DQ all of those. I'm going to DQ A, B, C, D, E, F, G. That's 7 of them. And we should see it happen here. A, B, C, D, E, F, G. So everything looks okay. I wonder why we have some errors though. And I didn't change anything from the old code, so I'm actually gonna bring this back to how I had it, because I'm curious what is wrong with that. I'll bring out that commented code. I'll leave it in there in case you guys want to play with it. So let's see what's up with this. Ooh, that's some nasty errors. Conditional jump depends on an initialized value, and it is happening on the DQs again. I think that's where it's happening. So if I just return 0 here and I test the code, I still have errors actually. Did I not say? So it's actually happening in the Enqueue. It's probably happening after a resize, if I was to guess. So like if I do here return 0, I get no errors. And if I try to insert one more thing after a resize, then I get errors. Oh, no errors either. Okay. Do I get errors there? So I guess my errors are actually coming from the print statement. Okay, so the errors are coming from the print statement. Whole queue. So we got I is equal to 0, capacity. And then we got valid queue front, back. Ah, I see. So the reason why I'm getting the errors is because when I'm printing out the queue, I also wanted to print out the empty spots, which technically are uninitialized. So what it's complaining about is that I'm printing out uninitialized information, which is just blank, but it could be garbage, which is fine. I was to make a point that I can print it. So if I want to avoid those errors from being printed out, I can just I can put an if statement here. Saying like if I is less than the size, or actually if I is less than or equal to the size, do that. Otherwise, go ahead and just do a blank spot. Here we'll do a special symbol for empty. What could I use that would be special? Like an X maybe? Maybe an asterisk. That is not right. If I is less than size, otherwise, is my size variable changed at this point? Do I ever even have, do I have a size variable? Yes, I do. Why is that I mean, that should get rid of the errors. So it does get rid of the errors, but is that actually what I'm supposed to be getting? I don't think so. Let me verify. Let me just comment this out. If I had it before. No, so I should get some stuff and then the invalid spots at the end. I guess I don't have size updated throughout this code. No, I do have it updated. The debugger for this one. Size is 3, back is 3, capacity is 3. Okay, that's fine. It's not the issue. Continue. Next time size is -2. Oh, that's not a good thing. I think I never updated size when I did the resizing. It's probably the issue. It shouldn't need to be resized. When I'm resizing an array, the size shouldn't change. I'm not sure where the error is. I'd have to go around and look at the code, but my size variable isn't reliably storing the size apparently, or so it seems. I am definitely increasing the size and decreasing the size on the Enqueue and DQ, but at some point, oh, I know what it is. Yeah. So when I'm doing my copying over here, I'm calling DQ, and that's actually decreasing the size because of calling DQ. So it's messing up the size variable. So one way that I can, I just have to restore it. So I'm gonna add size equals size or capacity +1 or not +1. I don't think +1. I think just capacity will be fine because I do the ++ here after the or the resize. So yeah, that's why. So that's why we had a -2. I was like, why do I have a -2 in size? It's because every time I'm doing a copy, I dequeue from the old one to queue to the new one, which is decreasing the size variable because I have minus minus in my dequeue. So that's why it was being decreased. That was a real bug that actually was in the code from last year. So nobody noticed it then when I coded it live. Maybe they were all scared. So that was a live lecture. So okay. But anyways, I'm happy that we fixed that code. Let's remove the breakpoint. So now that that is fixed, I is less than size. That is good. We're not getting the asterisks though, but I know that's not the issue now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're probably still getting the errors, but whole queue. 1, 2, 3. What is size in this case? Let's see. We fixed one bug, but now we still gotta fix this bug, I suppose. So size right now has 3, which is good. The next time it has 10. That is correct. There should be 10 things in there. Or wait, should there be though? No, there shouldn't be. So when we resize, it should be because the array is at the max capacity. Print this and print this. We would have been totally finished at 115 if it wasn't for this bug. So sad. Very, very sad. I have to see now. I don't want to leave you hanging on the. This is the last thing, and we can't. We gotta fix it. We can do it together. Send me good vibes. Okay, so for the Enqueue, we are increasing it. The resize shouldn't matter because size should be okay here. Let's put a debugger breakpoint there. So right now we have size equal to 0. That's fine. Then it's 1, 2, 3. And now it's 6. But the back is 4. But the capacity is 6. Okay. Okay, I see what's up. Okay, see, debuggers are like awesome. I should have done this size capacity thing before I changed the capacity because I want the original capacity because it's the current size of the array. So that was the issue. Those two lines were flipped. So now remove breakpoints. Okay, yeah, we got it almost. We just got to remove the less than sign. So this should probably just be I is less than size. Yep. Okay. So we got it. So oof. Okay. Moment of pressure there. And we got rid of all the errors. So awesome. So yeah. So the only things that we fixed right now was the fact that our size variable was getting messed up because of the dequeue. So to fix that, we have to make sure we update it after we call dequeue here. And one sort of ghetto-ish quick fix I could have done is I could have made a temporary variable here called like a size and then like size 2. So I could have been like size temp, have this whole dequeue nastiness run and then just re-upload it in. That would have worked too, by the way. And that would have been a simple solution, but you know, this is more elegant, I suppose. And then the real issue with the memory error is because we're trying to print out spots that are not initialized, which was by design, but I still wanted to fix that. So I just, see if it's not in the valid size, we just print an asterisk to fill it up with that. So yeah, so I mean, the errors that we fixed were not something big, like they don't detract from what I was showing you in the first place. But yeah, that's basically stacks and queues using arrays. Particularly this one's your circular queue. So now that you have seen how to implement them, you can actually go ahead and code your own versions if you want to use them. So yeah, that's pretty much it. You learn how to do them, you can code them now, so now use them to your advantage. Although in the real world, you're never going to code a stack or a queue. Like, it's very weird unless you're like coding it in assembly to optimize something. What probably you would be doing is you're using an import. So you can use a standard template library, or any programming language is going to have some sort of library that you can use that's called like stack. And then you basically have access to a stack and you don't need to code it. In fact, when you use a vector in C++, there's a push and pop function that works the same way as a stack. Same thing for the queue. So let me pull up really fast the reference for that. So queue and stack from standard template library. Trying to actually find proper references. Yeah, these two are okay. So here's the one for the queue, and here's the one for the stack. So only use these if your instructor allows you to use them for your class or for your assignments. If you're just learning a stack or a queue, more than likely they would make you code one because they want to see that you understand how they work. But in the real world, you probably just use one. So it is templated, and they don't have sample code. Well, you can see the member variables and things like that. Do they really not have sample code for neither of these? That's sad. But you can see it's called stdq. Okay, let me Google. Hold on, let me Google. QSTL C++. That's a good reference too. That one has sample code. I mean, it's pretty trivial, but I still want to show you some code. Don't make me code it. I don't want to code it right now. Geeks for Geeks can come to the rescue probably. Yeah, Geeks for Geeks is the real MVP. I just gotta find one for C++. Here we go. All right, so Geeks for Geeks coming for the rescue. They definitely have to have code. Yeah, there we go. So, don't ask me to sign it. Okay. So look at this. This is just like include stack, so that you can actually use a stack. So that's your import, and then you just make it. It's a template, so you gotta define the type there. Let me zoom in a little bit, and then just call it whatever you want. You don't have to call it stack, and then use dot push, just the same way as ours. Pop, same way. It returns something, so you can like see out it, and that's it. For the queue, pretty much the same stuff. So include queue, name the type, call it G whatever. There's a function to check whether it's empty or not, so you can avoid these weird issues. And then there's a front function. There's like peek and top, but again, the pure ones are going to be like pop. Wait, pop for queue. Well, I guess they use push and pop for the queue one. That I didn't remember actually. I seem to recall being Enqueue and DQ. But yeah, I guess they use pop for DQ, and then push for Enqueue. Weird. Yep, push and pop. Okay, that I actually did not remember. I'm a Python person, but yeah, still very cool. Okay. I mean, I probably knew that at some point, but I forgot it. But yeah. So that is what you would actually do. You wouldn't code this. You wouldn't worry about this stuff. You worry about like other more important things in your programming life. But you should still know how they work, because otherwise you can't use them, right? You gotta know how the tools work and how they're made so you can use them more effectively. So hopefully now you're comfortable with stacks and queues, and awesome for Geeks. I'll leave the link for the Geeks for Geeks on the description below as well. Okay? All right. Well, thank you all for watching, and I'll see you around.